Hello everyone, Mr. Steinman here. Today's video will go over the final page of the Unit 7 quadratics notes, particularly factored form, something that we already went over in notes. Here are just some examples here that will help us understand factored form even more. So, as we learned before, factored form is in the form f of x equals a parentheses x minus p, close parentheses, open parentheses, x minus q, where the x-intercepts are p and q, or 0 comma p, 0 comma q. But P and Q tell us what the x-intercepts are. So in this example here, it's asking us to first look at this graph here and circle the solutions on the graph. So we can just visually see that the solutions are there. Is the parabola concave up or concave down? Well, since it is a U shape, it has a minimum, it is concave up. And where do you see the values of the zeros in the equation? I see them because, well, we got f of x equals parentheses x plus 2 is x minus 1, and this is where I see them, here and there. Notice there's a p and there's a q. And that's how we interpret this graph in factored form. And then another example, to find the values of the solutions, set each parenthesis equal to 0 and solve the equation. So this is a way to find the values of the solutions in an intuitive way, because if we equal the parentheses to 0, then our y will equal 0, because anything times 0 equals 0. That's how we get our x-intercept, is make y equal to 0. So in this case, 0 equals x plus 2. We just use a good old algebra, something familiar, and you get x equals negative 2 here. It's one of the zeros or solutions. And similarly here, you just add 1 to both sides, you get x equals 1. And of course, those are our zeros up here, so we are continuing to validate our claim that the x-intercepts are negative 2 and 1 respectively. Now the next example, a little more complicated example. Given the equation g of x equals negative 3 times open parenthesis 2x minus 4 close parenthesis open parenthesis x plus 11 close parenthesis. What do we know about the graph? Well, here we go. So we know that it's concave down because a is negative. A equals negative 3. So we know that a is negative, so therefore we know it's concave down. And let's take a look. The axis of symmetry. Do we know the axis of symmetry? We can skip that one for now. Do we know the vertex? Let's focus on what we can easily figure out here. We know that the x-intercepts are something. So the way we figure out the x-intercepts, we could even say x-intercepts, we're going to equal those parentheses into 0. So for the first example, we got 2x, and you add 4 to both sides. You get 2x is equal to 4, so x is equal to 2. So one of these x-intercepts is 2 comma 0. And earlier, forgive me, the order should have been p comma 0 and q comma 0, because x-intercepts would have an x value first. And then for the other example of the other x-intercept, we would equal the other parenthesis x plus 11 equals 0. And in this case, it's much more simple. X equals negative 11. So another x-intercept we have is negative 11 comma 0. Now the y-intercept, this would be the value of y provided that x equals 0. We could put this in a calculator, such as like negative 3 times 2 times 0 minus 4 x, or that would be 0 plus 11. So that would end up being negative 3 times negative 4 times 11. 12 times 11 would equal 132. So our y-intercept is 0 comma 132. So with all this information, if we have we have a y-intercept that's pretty far up, I'm sure, and then x-intercepts 2 comma 0 and a negative 11 comma 0, and is a concave down graph. So we can say it looks something like that. And we don't necessarily know exactly what the axis of symmetry is immediately from this equation. So we can say x here and a vertex the same thing. But at least we know 3 points, the x-intercept 2 comma 0, that's negative 11 comma 0, and the other x-intercept 2 comma 0, and then the y-intercept 0 comma 132. So that is essentially the notes for the last page.